an A, there's an A right there, so 2 and 4 are gonna get me L or M. 2, 4, most opponents. Okay, so now look at 5, 6, 7. That gets me X. 5, 6, 7, simple dilemma. Okay, if you try to get the X all by itself, not using the dilemma, it's doable, but it would be very hard. So pay attention. I'm saying if you're going for something like an X and you see it twice in a consequent, that's a giant clue that simple dilemma is going to be the easiest way to solve the problem. Everybody got that? Okay. Okay, so let's do another one. 1, 2, 3. And the test has just 10 questions on it, just like this one that I'm doing. 4 is prove X or Y, and number 1 is not A, then X, then L. Number 2 is M or not L. 3 is not M. 4 is not M, then B, then Y. And 5 is A or B. Okay. So the very first thing I would think about is find X or Y together as a unit. I don't see that. Second thing is I would look for this. I would look for not X or Y, then blank. So I could do modus tollens and get X or Y. I don't see that either, okay? So the third thing I'm gonna think about, well, first thing I'm gonna look and see what the main operator is, and it's an OR. And this leaves me with 2 more ideas. I could get the X and then add or Y, or I could get the Y and add or X and then do a com to X or Y. So that's one strategy. This is another strategy. But there's one other thing that I'm thinking about, and that is this. When you're trying to prove a disjunction, sometimes you look out for this, then X, then Y. Because you might, if you see those 2 things, then you might think constructive dilemma is the key. So let me see. Do I have a blank then X? I do right here. It's got a negation, but don't worry about that. We can get rid of that. Do I see a blank then Y? I do right there. So I'm betting that the solution is to use constructive dilemma. So that's how I'm going to start the problem. Okay, what does that mean? It means, first of all, I need a then X. So that requires a not L. There's a not L in 2. It's part of an OR, so I need to find the opposite of M, which would be not M, which is conveniently located on line 3. So 2 and 3 get me not L. 2, 3, and that's disjunctive syllogism. Okay. I was going to use this not L to do a modus tollens with line 1, and that gets me A, then X. 1, 6, modus tollens. The negation drops off when we do the modus tollens. So I got the A, then X. Now let me try to get the B, then Y. It's in a conditional, which means I need a not M, and gosh darn, there's a not M right there at 3. So we can say B, then Y, from 3 and 4, modus ponens. Okay. All right, so the only thing I would need left to do constructive dilemma would be A or B. And look what's sitting there on line 5. A or B. So 9, I get X or Y from 5, 7, and 8. 5, 7, and 8, constructive dilemma, and I would take that off, because that's something we hadn't used before. Okay, any questions about this?
Yeah, I would not have, like, I was trying to solve it before you to see if I would have done what you would have done.
Yes.
I didn't do that, and I got it wrong, of course, but I just don't know how to know which one to use. I did say constructive dilemma was like the one I wanted to use because I knew there was an or and then two conditionals,
Mm-hmm.
but I don't understand how you're, like, working it backwards.
Well, I'm just working it backwards.
I know, but I don't.
Right? Okay, you know what 3 parts you need.
So,
So just focus on one of those parts. So the first thing I needed was one of the conditionals, then X, right? And look right here, there's a then X. Forget about this stuff, there's A then X. We know we need that. Never mind the negation sign, because we can find the opposite of L, we can get A then X, because the negation will drop off. So I know I need a not L, right? So I'm looking for not L, just draw a line right here, right, on your paper to leave a mental trail, and it's in an or, so how do I get the right side out of an or? I find the opposite of the left side, that's right there, so I do a disjunctive syllogism, that leaves me with a not L, and then, you know, I've left a line right here, it says, hey, this is where you want to use the not L, so I think, oh, I can do modus tollens with this one and this one, so I get A then X. Okay, that's one piece of the constructive dilemma, and now just say, what was the next piece? So like, you know, I would have this drawn on the side, and I'd say, now let's go get the then Y, and it's a B then Y, right? And that requires a not M, and there it is, right there. So that's just, you know, one step, most opponents to get the then Y. And then I would say, well, that means I need now a disjunction between A and B. I need A or B, and I look around, there it is. Okay, so the fact that you figured out that it was going to be solved by constructive dilemma, that's 90% of the battle. You just gotta, a lot of times you can work backwards through the problem, figure out how to start, and then you might forget, well, then what I was gonna do, because there's like 3 different phases. Work through the problem again and say, oh, well, I already did one, and oh, the next thing I need to do is that, right? So I have noticed that on a lot of exams, there's people who draw, you know, these things and the lines and the shapes and stuff like that, and it helps them, right? All those aids. When you've done about 1 million of these, you can just look at it and say, blah, and you just know how to do it, right? But that's not what we're at, so we gotta work it backwards. And sometimes you have to work it backwards a number of times to remember what your next step was, okay? And the problems on the test are not very long, so you're not going to get, hopefully, lost, right? Like, I was doing this, why was I doing that? Okay, they are not that long. 1, 2, 3, 4, so I'm on 5. Okay. 5, I have to prove L then M and M then L. I have not J and K. I have K and L, then M, and I have not M or L. Now, I don't see that giant blob L and M and M and L, okay? I don't see its opposite in an antecedent. So I notice the main logical operator is an and, okay? So what that means is I can treat this as two problems. Go get the L then M, and get the M then L, and then put them together. So goal 1, goal 2, and then I'll just put them together. Okay, so let me see, do I see an L then M? Well, I don't. Now, this is the trickiest problem. And actually, instead of going for this one first, let me go for this one first. M then L, okay? I don't see an M then L, but I do see M's and L's together, okay? And we need a conditional. And I remember, oh, there's a rule that lets me convert an or to a then. And that's called material implication or implication. And what happens? Well, the first thing changes its sign, so not M becomes M, or becomes then, and the second thing stays the same. Okay, so that's from 3 by implication, and that's exactly what we needed. Okay, so there's one part down. Now we need the L then M, okay? And actually implication, this is a rule we hadn't used before, so tick, okay. Now, this is where that ticking off the list would become really helpful, because we're looking for an L then M, and we don't see one anywhere very obviously, but there's one rule that we haven't used yet, and that's exportation, okay? So if you look at exportation, it lets you take this thing and kick it into the consequent. And when you do, so we get 5, we get K, then L, then M. That's from 2 by exportation, okay? And now I might not have ever seen that if I hadn't realized, oh man, I'm stuck. What have I not used? Oh, exportation.